Hi, and welcome to Statistics Day 7. Today we're going to be talking about the correlation coefficient, and it's more graphic calculator work. The number that we use to measure both the strength and direction of a linear relationship is called the correlation coefficient, and we use the lowercase r to denote this. This is used with bivariate data, which means bi is 2 and variate would be your variables. So when we have x and y values that we need to work with. One thing we need to make sure we do is turn our diagnostics on the calculator, because if we don't turn our diagnostics on, then you're not going to be able to find the R value, because it needs the diagnostics on. To turn your diagnostics on, you need to hit second 0. So turn on diagnostics. You have to do second and the 0 button. And then you want to hit, you can see that the alpha button is already highlighted, so you want to hit the X inverse button, which is X to the negative 1. And that brings you to the D's, and then arrow down till you see diagnostics on. And when you get to there, that was like 10 places down on mine, you hit enter. And then enter again. You're looking for the word done to pop up on your screen. If done pops up on the screen, then that means it turned the diagnostics on. If done is not on the screen, then it did not turn it on. Some of the calculators in the classroom will already have this on for you, but when the test comes, the day of the test, it will not necessarily be on because we'll have reset everything, so you need to turn that on. All right, so for example 1, the coach of a basketball team made the following table of attempted and successful baskets for 8 players. This should be 11, not 12. So the attempted baskets are 10, 11, 12, 13, 14, 15, 17, and 19. And then the successful baskets were 6, 7, 9, 8, 10, 11, 14, and 15. Okay, when you put that data into the calculator, you need to put this in list 1, sorry, the X in list 1, and the Y's in list 2. And that's always how it's going to work with these tables when they give them to you in horizontally instead of vertically. The top is always X or L1, and the bottom is always Y, L2. So when I put that in, it says find the value of the correlation coefficient. I need to then go to, after I get my data in, I need to go to Stat. I need to go back to the original Stat menu, and then arrow over to Calculate, and then go down to number 4, and this is a lin reg, and AX plus B after it, which means it's a linear regression, or a line of best fit is a linear regression, and that means that our data would look like a line. And when we do this, we'll get a menu, a screen that pops up that says y equals ax plus b, y equals mx plus b. It's a slope, regular line, equation of a line. It gives you a value for a, it gives you value b, it gives you an r squared value, and it gives you an r value. A is your slope, b is your y-intercept, R is the value that we're looking for. R is the correlation coefficient. And in this case, a correlation coefficient, and we usually talk about them to the nearest hundredths, would be 0.98. When we have correlation coefficients, they fall between -1 and +1. Okay? And if it's close to a +1, it would be a positive slope, and it would be a what we call a strong linear relationship or strong linear correlation. If it's going as a negative slope and it's r is near -1, then it would be a strong negative correlation. When r is equal to 0, there's absolutely no linear relationship between the two values. Sometimes it looks like this first plot, and sometimes it appears as a different type of graph. And this appears to be a parabola. And since that looks like a parabola, you would think that that would be a quadratic regression that you would use on that one instead of a linear regression, because linear is for just a line. So if it looks like something other than what you're testing it for, then it would be close to 0. The absolute value of r is close to 1. The data have a strong linear relationship. Values between 0 and 1 indicate various degrees of moderate correlation. The sign of r matches the sign of the slope of the regression line. So if r is positive, your data is going to have a positive slope. If r is negative, your data is going to have a negative slope. All right. For number 2, I typed this all into the calculator. Alrighty, so it says an automotive engineer is studying the fuel efficiency of a new prototype. From a fleet of 8 prototypes, he records the number of miles driven and the number of gallons of gasoline used for each trip. So the top is my X, and the bottom is my Y, and so that makes this L1 and this L2. So based on the context of the problem, do you think the correlation coefficient would be positive, negative, or close to 0? Well, just at looking at the data itself, the more miles I drive, the more gas I use. So if they're both increasing, that would be a positive correlation. Okay, that would be a positive correlation coefficient. So that would mean, you know, it would be the more you drive, the more gas you use if you look at this data. For letter B, based on the scatter plot of the data, do you expect the correlation coefficient to be close to -1, 0, or 1? Well, if we look at the scatter plot, this is a real loose scatter plot, but it kind of looks something like this. That would mean we'd want it to be close to 1. Part C, use a calculator to find the equation of the regression line and determine the correlation coefficient. Well, once I put my data in, I need to find A and B and my correlation coefficient. So it's going to be y equals ax plus b, and I have a value for A, and typically go at least 3, maybe 4 decimal places, so it'd be 0.0299x plus 0.7477. I got that off of the calculator. I'm not going to have to find that by hand. So find the equation and then find the correlation coefficient. So R, when I look at my calculator, I get 0.99. that is very close to 1, and that would indicate that we have a positive correlation. In this case, it would be a strong positive correlation. All right, last problem. The produce manager of a food, that's not a store, food store, noted the relationship between the amount the store charged for a pound of fresh broccoli and the number of pounds sold in 1 week. His record for 11 weeks is shown in the following. This problem kind of ends, but what we're going to do is we're going to see what's going on and determine the correlation. So find R here, find our correlation coefficient. So I have to put all my data into the calculator. This is X, this is Y, this is L1, this is L2. After I put it in the calculator, I'm going to look at the graph and look at the picture of it. And again, this is just a loose interpretation of the graph. It's kind of running low on energy tonight. Normally I would actually draw a graph, label on my sides, plot my points. This would be my cost, and this would be pounds purchased. Okay, I'm going to do a little bit better job of that. But if you look at the scatter plot, there is no real pattern. It doesn't look like a line that's increasing. It doesn't look like a line that's decreasing. So this would be a weak correlation or no correlation. And on my calculator, R is negative 0.46. So it's getting pretty close to 0, which means there's really no correlation. You need to be really close to 1 to actually see a very strong positive correlation. All right, a warning about cause and effect. The correlation coefficient is a number that measures the strength of the linear relationship between the two sets of data. However, simply because there appears to be a strong linear correlation between two variables does not mean that one causes the other. There may be other variables that are the cause of the observed pattern. For example, consider a study on the population growth of a city. Although a statistician may find a linear pattern over time, this does not mean that time caused the population to grow. Other factors cause the city to grow, for example, a booming economy. Okay? So just because there's a strong relationship doesn't mean one causes the other. So in summary, the correlation coefficient is a number between -1 and +1. It includes -1 and +1. If you end up on -1 or you end up on +1, you have a perfect linear relationship. Okay, and that's the next bullet down. The closer you are to 1 or -1, the stronger your relationship is. When R is equal to 0, there's absolutely no linear relationship that exists between the data values. When the absolute value of R is close to 1, the data have a strong linear relationship. Values between 0 and 1 indicate various degrees of moderate correlation. The sign of R matches the sign of the slope of the regression line. And finally, a high correlation coefficient does not necessarily mean that one variable causes the other. All right, that's it for today.